Mathematics is not about writing and practicing until you have practiced it so much that you just know how to do it. Mathematics is about using your whole brain and actually understanding what you are doing so that you won't have to practice it 100 times to finally be able to do it, but really understand it the first time and then always be able to do it. Even if you've done it 2 months ago, and then after 2 months you see that same problem again, but because you really truly understand it and doesn't care about if you practiced it enough, you will be able to do it because you understood it. And it's about using your whole brain, not only the left hand side. When you think mathematically, truly think mathematically, and not only do things because it works, then you understand mathematics and then you enjoy it. Mathematics is not about only using your left half of your brain. Mathematics is using the whole part of your brain. When I do mathematics and I really struggle, it's always nice like afterwards when you truly understand, you feel exhausted because you've used your whole brain. Sometimes when you're writing an exam or when you're doing mathematics, it feels afterwards like you've used your whole brain and not only the one part, and that's why it's awesome. The mathematical language is quite objective and precise, with the emphasis placed on precise. The Oxford Dictionary describes the word precise as taking care to be exact and accurate, especially to minor detail. Therefore, we give very precise definitions to English words in the mathematical language. These words include and, if, and they all have multiple uses in the English language, but they only have one specific meaning in the mathematical language. For example, differentiate. Differentiate between two objects. You can say something like that in English, but differentiation means something specific in mathematics. The mathematical language is very precise and objective. The focus and emphasis is placed on the word precise because the Oxford Dictionary explains the word precise as taking care to be exact and accurate, especially about minor detail. And the emphasis is placed on precise because that is exactly what maths is. It is precise. You have to form accurate statements about real things, imaginary things. That's what mathematics is about. Okay? And for mathematics to be precise, we need one definition only. For certain words that are in English might have two definitions, but in mathematics that can only have one definition for it to be very precise. That's, for example, and, if, or, differentiation, rate. Those are all English words that might have two definitions in English, but in mathematics it only has one precise definition. We introduce symbols in mathematics because we don't really care about what something looks like in mathematics. We only care about what it actually means and what it means to us. Because in mathematics, it's all about the thinking, not about the writing. Okay, so if we were to write a whole sentence in English, that would be, for example, 10 words long. That same sentence in English can be represented in the language of mathematics using only 5 symbols, and that's what we actually care about. So if we have the sentence, for example, Naomi has 4 necklaces, how much more, the unknown, does she need to complete her collection of 10 necklaces? That was a completely long sentence in language English, but this is how it is represented in the language of mathematics. And we have different symbols as well. For example, the word and in English can be represented by this symbol in mathematics. Variables can also be used to represent statements and not only unknown numbers. For example, the statement x is equal to gravity exists. This is a statement and not only one specific number. And just like we can form general principles about unknown variables such as x, when x represents a number, we can form statements about x when x is, we can form general principles about x when x is a statement. It's exactly the same thing. We should think of it as the same thing, because here x is a number, and here x is just a statement. This is x times 2. This is a general principle in mathematics that is 2 times x is equal to x times 2. It's the same thing. And just as like here it's a number, we use x is equal to gravity exists, we can say x and x. And that is only true when x itself is true. And basically what that says is that gravity exists and gravity exists is only true when gravity exists. So that's like x and x is true only when x is true. Okay. Just like x, which is an unknown variable, can represent numbers, x can also represent statements. For example, we can say that x represents the statement gravity exists. And then as we form general principles about x when x is a number, we can form general principles about x when x represents a statement. Okay, using the example x is equal to gravity exists, we can form a general principle about it. X and x is equal to x, which basically means that when you say gravity exists and gravity exists, it's the same when saying gravity exists, because it's exactly the same thing. Because x and x is only true when x is true. And it is obvious to say that gravity exists and gravity exists is true only when gravity exists.